So to start talking about glycogen, we actually need to sort of review what glycogen even is. Now, glycogen is just multiple bonded up glucose that is mainly in the skeletal muscle, but can also be in the liver. And glycogen is just how our body stores energy, either when we need it or when, there's a time when we eaten all our food and we had a good meal, and that's where glycogen will come into play, where we can store that glucose for a necessary time. Now, there are two key terms that we have to know through our discussion. And there are two key terms that happen with glycogen formation and glycogen breakdown. These are basically the, I guess you could say, technical terms for those processes. So the first one is glycogen formation, which I have in green. And glycogen formation, the technical word for that is going to be glycogenesis. So glyco means glycogen, genesis means the creation of. So glycogenesis is the creation of glycogen, and the opposite of that is glycogenolysis. So let me just put it down here. Glycogenolysis. So glycogenolysis, we have glyco still there, and lysis means the breakdown. So glycogenolysis is the breakdown of our glycogen to glucose, and glycogenesis is the production of glycogen from glucose. Now, we know as a sort of refresher that when we have glucose, let's say we had a meal, glucose will be turned to glucose 6-phosphate through our glycolysis process, and through our glycolysis we produce pyruvate. Now there are two ways in which we can go with this pyruvate. We can go aerobic and go to Krebs cycle, producing these byproducts as well as ATP, or we can go through lactate fermentation, and this is when we don't have oxygen, we're in an anaerobic environment, we don't produce a lot of ATP, but that is our glycolysis. We're talking about glycogen, we're talking about glycogenesis and glycogenolysis. So we obviously start off with glucose, and let's go with our glycogenesis. Now with glycogenesis, we have two key enzymes that we have to understand, we have to sort of memorize. With the first one, this is glycogen synthase, and the main thing you have to understand about glycogen synthase is that this creates alpha 1,4 linkages, or alpha 1,4 glycosidic bonds. What does an alpha 1,4 glycosidic bond look like? Well, this is exactly what it is right over here. So we have our glucoses bonded together in this alpha 1,4 linkage right here, and glycogen synthase is going to create this bond. Now what does branching enzyme do? Well, it's going to create the other bond. This is alpha 1,6, the glycosidic bond, and this is going to be this guy right here. So this is the bond that we'll be creating over here, the alpha 1,6 glycosidic bond, and those are two enzymes that you have to know for glycogenesis. Anytime you see these enzymes, know that we are in glycogenesis. Now, what promotes or inhibits glycogenesis? So let's think about this through a conceptual understanding. If we're taking glucose and we're turning into glycogen, that means we're storing energy. And if we're storing energy, that means we don't need it for right now. It's like, for example, if you're moving into a new house and you have a bunch of stuff, you don't need that stuff when you're going to a new house. Like, you don't need like all these past memories of like photos or toys or whatever. You don't need those. What do you do with them? You store them. You put it in a storage facility. So our body at this moment does not need glucose. It's as if we had a meal. Like, for example, we had dinner. Our body had enough glucose that it needed for energy, and it's going to turn that glucose into glycogen through glycogenesis. So the things that will be able to promote glycogenesis include insulin. And for those of you guys that don't know, insulin is a hormone that is released when we have blood glucose in our bloodstream, and this hormone basically allows the uptake of glucose from the bloodstream. So let's say we just ate dinner, insulin will be released. And we also have glucose 6-phosphate, which will also be promoting our glycogenesis. So that is glycogenesis. Now let's move on to glycogenolysis, which is the breakdown of glycogen. Now we also have two enzymes as well, and they're actually kind of similar, but we have phosphorylation over here, and we have debranching enzyme. But I mean, it's pretty much very similar. We have alpha 1,4 linkages that are going to be broken in with the glycogen phosphorylase, and with our debranching enzymes, we're going to have our alpha 1,6 glycosidic bonds or linkages being broken. Now, what are some conditions in which we would be able to promote this process of glycogenolysis? Well, glycogenolysis is the opposite of glycogenesis. So this is where we're satiated, we had a good meal, we're resting. Over here, this is when we need glucose. Maybe we're in a stage of starvation, or the sympathetic nervous system has been activated, we're running from a threat, we need glucose available. So the sort of things that will be able to promote glycogenolysis are going to be glucagon. Glucagon is a hormone that does the exact opposite of what insulin does. So instead of promoting the uptake of glucose into the bloodstream, this is going to promote the glucose just being in the bloodstream, so it can be readily available for the entire body. Then we also have epinephrine, and this is a hormone that is very crucial when we're in our sympathetic nervous system. And we also have AMP. These are things that are going to be activating our glycogenolysis, while over here we had insulin and G6P that would be activating our glycogenesis. Now, through that entire process, the number one thing we have to know, especially for the MCAT, is that glycogen phosphorylase and debranching enzyme are associated with glycogenolysis, while glycogen synthase and branching enzyme are associated with glycogenesis. Remember, when you have glycogen and then the synthase or phosphorylase, these are going to be breaking or forming those alpha-1,4 linkages, while branching and debranching are going to be breaking or forming those alpha-1,6 linkages.